Welcome to Pre-Calculus. Today we will investigate applying the binomial theorem to expand binomial powers. We'll take a look at three examples. Our first example is a simple binomial n minus 2 to the power of 5. We'd worked on these examples previously just by expanding that. Remember, I could really say that n minus 2 to the power of 5 is n minus 2 times itself 5 times. And with something like this that's simple, we probably could actually multiply that out. In fact, we did that on a previous lesson. But if I have more complicated examples like we saw in that same lesson, it really becomes tricky to multiply out. It's a lot of keeping track of coefficients and powers. And definitely with higher powers, the work becomes more and more burdensome. And so what we've got is really the opportunity to look for some type of formula or pattern. And that's given to us in the binomial theorem. And essentially what the binomial theorem offers to us is a formula. So let's just give the formula in general terms first, and then we'll apply it to this example. So if I've got a binomial in general terms x plus y to the power of n, that's going to be equivalent to the sum. So we're going to think about this as a series from k equals, let's say, 0 up to n of this statement. So each of our terms is going to look like this. It's the combination if I have n items and I'm choosing k of them. We'll remind how to calculate that combination as we go. Times base x to the power of n minus k times y to the power of k. So that's our formula, and really it's a formula that gives us a series. And so what I need to do is just identify what's my n, what's my k, and then what are my x and my y. So I've got it lined up here. It turns out my x is my n. So what I'd like to do is rewrite this for this specific question. So we'll set it up as n minus 2 to the power of 5 equals, so our sum is going to be from k equals 0 to our n value. Our n value is always the power, it's the power of 5. So we'll have those terms. And I want to calculate it as 5 choose k. So the n value is fixed. K value is going to change based on which term I'm looking at in the expansion. And then I've got x. So my x is this variable n to the power of n minus k. So the n value we had was in fact 5. So it's going to be 5 minus k times y. My y is actually a negative number, negative 2 to the power of k. So all we've done in that step is write our binomial to the power as a series. Now what I want to do is I want to expand that. So that's going to be equivalent to, so I'm going to make it customized for each term. So I'm going to start with k value of 0. So it starts off 5 terms, choose 0 of them, to the power, times n to the power of 5 minus 0 times negative 2 to the power of, in this case, 0. So we'll do the simplification in a moment. Right now I'm going to write plus, and I want to start the next term. So we'd used 0. Now I'm going to start with 1. So I have combination 5 choose 1 times n to the power of 5 minus 1 times negative 2 to the power of 1. Continuing on, we got coefficient 5 items, choose 2 of them now. So notice my n value went up, times base n to the power of 5 minus 2 times negative 2 to the power of 2. keep going. And so I'm going to wrap around here. The expansion has gotten to the end of the screen on the right. So now I'm going to do coefficient 5 items, choose 3 times n value to the power of 5 minus 3 times negative 2 to the power of 3. 2 more terms left. So now I've got 5 items, choose 4 of them, times the base n to the power of 5 minus 4 times negative 2 to the power of 4. And then our last term, 5 items, choose 5 times n to the power of 5 minus 5 times negative 2 to the power of 5. So that's the expansion. Now what we need to do is we need to evaluate each of these terms. So for my first term, I want to calculate 5, choose 0. So that's a combination. And what it's saying is if I have a group of 5 objects and I want to take 0 of them, how many different groupings of objects could I select? So this case is a little bit awkward because I'm choosing none of them. Let's remember, we'll do this in a couple ways. Let's remember how I actually calculate a combination. So if I have, let's call them n items that I'm choosing k of them, that's equivalent to n factorial over n minus k factorial times k factorial. So let's apply it with our specific one, 5, 0 here. So that's going to be 5 factorial over 5 minus 0 factorial times 0 factorial. And recall from probability and statistics that a factorial is 5. If I have 5 factorial, it's 5 times every other whole number down to 1. So that's how I actually evaluate that type of operation. And that's going to be over 5 minus 0, 5 factorial as well. So a lot of times what we see with combinations is a cancellation. In fact, all those factors are going to cancel. And then 0 factorial itself is defined as 1. So it turns out that the value of 5, choose 0 is 1. So let's simplify that first term. So the way I'm going to write this, it's going to be the coefficient. So these always give us our coefficients. 1, n to the power of 5 minus 0 is n to the 5th. And then negative 2 to the power of 0, anything to the power of 0 has a value of 1. So it's going to be 1 times n to the 5th times 1. Let's pick up our second term. So now it's plus 5, choose 1. So again, I could calculate this here. We'll calculate it one more, and then we'll show another strategy for evaluating combinations. So it's 5 factorial over 5 minus 1 factorial times 1 factorial. So again, expanded, that's 5 times 4 times 3 times 2 times 1, all over 4 factorial, which is 4 times 3 times 2 times 1, and then 1 factorial, like 0 factorial is defined as 1. So what we'll cancel here are my 4, 3, 2, 1 has the value of 5. And again, what we're saying there is if I have a group of 5 objects and I want to choose 1, how many different objects could I choose? 5. So it's going to be, for my second term is plus 5 n to the power of 5 minus 1 is 4 times negative 2 to the power of 1 is times negative 2. So calculating combinations isn't difficult, but it creates a lot of work here. So what I wanted to offer was a second strategy. So let's calculate this next one. It's 5 objects, choose 2. I'm just going to go over to Desmos and calculate it there. So on Desmos, the way that we would calculate a combination, if you just want to select it as a function, you would go to the keypad, select functions, and we go to stats, statistics, and the operations there in that tab. So it's an operation lowercase n, capital C, lowercase r, parentheses. We are interested in 5 objects, choose 2. That's telling me 10. Let's check our previous one. So you can select the operation from the tab. You can also just type lowercase n, capital C, lowercase r. So we had calculated 5 choose 1 as 5, and that looks good. So we can see that it is calculating correctly. So let's take our 5 choose 2 back. That's got a value of 10. So our next term is going to be plus 10 times n to the power of 5 minus 2 is 3. Negative 2 squared is 4. All right, so now you kind of get into a groove. Again, I got to calculate 5 choose 3. Since I got to calculate 5 choose 3, 5 choose 4, 5 choose 5, I'm going to do those all at once. Now that I have a good calculator tool here. So NCR, 5 choose 3. So that's also 10. Let's just calculate out here. NCR, 5 choose 4 is 5. So I'm starting to see a pattern here. NCR, if there is a pattern, 5 choose 5 should be 1. And it is. So I'm just going to record those down so that I can put them in place. Again, 5 choose 3 is 10. 5 choose 4 is 5. And 5 choose 5 is 1. Let's head back to our note screen to finalize that example. So I'll start with this. We're here in this second row now. 5 choose 3. So we calculated that as 10. And then n to the power of 5 minus 3 is n squared times negative 2 cubed is negative 8. Okay, next term, 5 choose 4, we calculated on Desmos as 5 times n to the power of 5 minus 4 is 1 times negative 2 to the power of 4. That's negative 2 times negative 2 times negative 2 times negative 2. That's 16. And then my last term here is 5 choose 5. We calculated that on Desmos as 1 times n to the power of 0. Anything to the power of 0 is just 1. I'll write it there, but we're going to cancel it. And then negative 2 to the power of 5 is going to be negative 32. So that's ready now for us to just finalize. Once I get it in a row like that, I just want to simplify. So 1 times 1 is 1, n to the power of 5. That's all I got to write for my first term. Second term is 5 times negative 2, so minus 10, n to the power of 4. Third term, 10 times 4 is plus 40, n to the power of 3. 10 times negative 8 minus 80, n squared. 5 times 16, that's 50 plus 30, so that's positive 80n. And lastly, 1 times negative 32 is minus 32. And that completes the expansion of that binomial power. So we did a lot of work here just to kind of set up how do we use this rule. Let's take a look at a second example that has a few more parts, but it's still pretty simple, except it's to the power of 7. So this is x minus 2y to the power of 7. And as you can imagine, expanding powers that are bigger it's going to have 7 terms, so it takes more time and more work. But the rule is going to help us. So again, I want to put this formula. So it's going to be the summation from k equals 0. You always start with 0 to the power of, or to the final term that equals that power. So I would put a 7 above the summation. So I'm going to have 7 choose k of the objects. So we'll change the k value based on which term we're trying to evaluate. My x is in fact x. Your x is your first term to the power of 7 minus k times my y, which in this case is negative 2y. You want to include that full second term along with its sign if it's negative to the power of k. So again, that sets it up just as a sum. What I would like to do then is convert it over to an actual binomial expansion, a series. So I'm going to start again with k value of 0, and then we'll count up by ones up to k value of 7. So my first term is going to be 7, choose 0, times x to the power of 7 minus 0 times negative 2y to the power of 0. We'll keep going. What I'll do is I'll alternate so we can kind of see our terms, dark blue, light blue. So now I'll do plus 7, choose 1, times our base x to the power of 7 minus 1, times negative 2y to the power of 1. Notice the only thing that's changing from term to term is the k value. So now I've got plus 7, choose 2, of x to the power of 7 minus 2, times negative 2y to the power of 2. Now we'll go plus 7, choose 3, times x to the power of 7 minus 3, times negative 2y to the power of 3. Plus 7, choose 4, x to the power of 7 minus 4, times negative 2y to the power of 4. Now to the fifth term, actually our sixth term, since we started with k value of 0. That's 7, choose 5, times base x to the power of 7 minus 5, times negative 2y to the power of 5. Next is going to be plus 7, choose 6, times x to the power of 7 minus 6, times negative 2y to the power of 6. And lastly, plus 7, choose 7, of x to the power of 7 minus 7, times negative 2y to the power of 7. So we got it all expanded. Now what I need to do is calculate different combinations from groups of 7. So again, now that I know that I need them from 7, choose 0, all the way to 7, choose 7, I can calculate them all at once. So we'll start with 7, choose 0, but remember anything choose 0 is going to be just one group. So again, I'll type NCR, 7, choose 0, that's 1. NCR, 7, choose 1, that's 7. NCR, 7, choose 2 is 21. NCR, 7, choose 3 is 35. Now at some point we're looking for a symmetry that'll start going back in the pattern. Again, I got 1, 7, 21, 35. 7, choose 4, 35. So I can start predicting now. I think 7, choose 5 is going to be 21 if I look back at my list. And that is 21. NCR, 7, choose 6 matches our 7, and then NCR, 7, choose 7, again, is a group of 1. So again, I'm going to record those so we can use them. 7, choose 0 was 1. 7, choose 1 was 7. 7, choose 2 was 21. 7, choose 3 was 35. 7, choose 4 was also 35. And then we kind of go backwards. 7, choose 5 is 21. 7, choose 6 is 7, and 7, choose 7. Again, if you're choosing 7 objects out of a group of 7, there's only one group you can choose. So that makes quick work of the coefficients. Let's head back to our note screen just to finalize those. So I'm going to record here now. We'll change our colors again so that we are matching. We'll go with purple here. So purple is going to match with dark blue. So 7, choose 0 is going to be 1 times x to the power of 7 minus 0 is x to the 7th, and then negative 2y to the power of 0 is 1. Next term is going to be 7 choose 1. So again, we've calculated that as 7 times x to the power of 6 times negative 2y to the power of 1, which again is going to be negative 2y. Our third term, 7 choose 2, we had calculated as 21 times x to the power of 5. Once you notice the pattern in the power of 7, 6, 5, you kind of got it. And the negative 2y squared is going to be 4y squared. Plus 7 choose 3 is 35. X to the power of 4. And then I'm cubing negative 2y, and that's going to be negative 8y cubed. Remember, when you cube things, really any odd power keeps the negative. Now we're on our second row here. So 7 choose 4 is also 35. X to the power of 3. Now I'm raising negative 2y to the 4th power. That's going to be positive 32. That's to the 5th. Let me correct that. That's going to be 16y squared. Next term. So now I'm calculating. Now I'm calculating here 7 choose 5. So 7 choose 5 was 21. I'll wrap around here. So plus 21 x to the power of 2. That's 7 minus 5 times negative 2y to the power of 5. So that's going to be negative 32y to the 5th. Okay, now 7 choose 6 is calculated as the coefficient 7 times x to the power of 1 times negative 2y to the power of 6. To calculate those powers, I'm looking at the last negative 2 to the power of 5 was negative 32. So power of 6 is just double that, 64. Again, positive because it's an even power of 6. And then my last term, 7 choose 7, had a value of 1. X to the power of 0 times negative 2y to the power of 7. So again, 64 was my last power of 2. Times negative 2 is going to give negative 128 y to the power of 7. So then from that version, I just need to multiply my numbers and write a final form. So my final form here is going to be 1 times x to the 7th, x to the 7th. 7 times negative 2 minus 14 x to the 6th y. 21 times 4 is plus 84 x to the 5th y squared. 35 times negative 8. So here I'll just make use of my on-screen calculator. That's minus 280 x to the 4th y cubed. Then I've got 35 times 16, so that's really double 280. So that's going to be, if we think about double 280, that's going to be 560 plus 560 x cubed y to the 4th. Next term is going to be 21 times negative 32. Let's multiply that one out. 21 times negative 32 is minus 672 x squared y to the 5th. And then the numbers do start to decrease now. What we're looking at now is 7 times 64, which is 448. X, y to the 6th. And then my last term in this series is going to be 1 times negative 128, so minus 128. Y to the power of 7. The x term there drops out because it's to the power of 0. And I'm going to box that, and that completes that expansion using the binomial theorem. Let's take a look at one final example that, again, is to the power of 7, but involves a power in the binomial. So again, now that we have our pattern, I'm just going to set up the summation from k equals 0. Always start with 0 to the power of 7. So it's going to be 7 choose k. And kind of as a side effect, once you've calculated different combinations from a group of 7, they don't change. So we've already done that. If I line up, so remember the general form is x plus y to the power of n. My x is going to be x squared. So it's x squared to the power of 7 minus k. My y is actually 2y. So 2y to the power of k. That's the sigma notation version. Now let's convert it to an actual series here. So we'll start off, so it's going to be 7 choose 0 of x squared to the power of 7 minus 0 times 2y to the power of 0. Second term, plus 7 choose 1 of x squared to the power of 7 minus 1 times 2y to the power of 1. Third term, so that's going to be 7 choose 2 for the coefficient times base x squared to the power of 7 minus 2 times 2y squared. Third term, fourth term in fact, plus 7 choose 3 for the coefficient x squared to the power of 7 minus 3 times 2y to the power of 3. Now plus 7 choose 4 of x squared to the power of 7 minus 4 times 2y to the power of 4. Next terms plus 7 choose 5 times base x squared to the power of 7 minus 5, all times 2y to the power of 5. Just a couple terms left. Now I got 7 choose 6 of x squared to the power of 7 minus 6 times 2y to the power of 6. And our last term is plus 7 choose 7 of x squared to the power of 7 minus 7. So that one's going to drop out, times 2y to the power of 7. So again, once I got that expanded, I just want to evaluate the coefficients and the powers. So now what I've got is 7 choose 0. We'd calculated that from our previous example as 1. X squared to the power of 7 is going to be x to the power of 14 times 2y to the power of 0 is 1. Next term, plus 7 choose 1, we had calculated as 7. X squared to the power of 6, we multiply the 2 and the 6 to get power of 12. And then 2y to the first is going to be times 2y. 7 choose 2 has the value of 21. So a group of 7 objects, I'm choosing groups of 2. I could choose 21 different groups of 2 out of 7 objects. Times x to the power of 7 minus 2, that's x to the power of 2 to the 5th, that's 10. And then 2y squared is going to be 4y squared. 7 choose 3, we'd calculate it as 35. And then x squared to the power of 4, 7 minus 3, it's going to be x to the power of 8. Times 2y to the power of 3, that's 8y cubed. Now we're on our second row in the expanded version. 7 choose 4 was also 35. X to the power of 2 to the power of 3 is going to be x to the power of 6 times 2y to the power of 4 is going to be 16y to the 4th. 7 choose 5, we'd calculate it as 21. x to the power of 2 to the power of 2 is going to be x to the 4th, and then 2y to the power of 5 is going to be 32y to the 5th. Our 7 choose 6 has a value of 7, so plus 7. X squared to the power of 1 is just x squared, and then 2y to the power of 6 is going to give us 64y to the 6th. And then our last term, 7 choose 7. You got a group of 7 objects. You're choosing 7 of them. There's just one group possible. And then x to the 4th to the power, I'm sorry, x squared to the power of 0 is just 1. And then 2y to the power of 7 is going to be 128y to the 7th. And lastly, we just want to finalize. So I just got to make my multiplications. 1 times 1 times x to the power of 14 is x to the power of 14. 7 times 2 is 14 as a coefficient, x to the 12th y. 21 times 4 for my next term is going to be coefficient of 84, x to the 10th y squared. 35 times 8. So that one, let's actually multiply that out. 35 times 8 is going to give us 280. X to the power of 8 y cubed. 35 times 16, that's my next product, which is really just double 280, so that's plus 560, x to the power of 6, y to the power of 4. 21 times 32, looks like I hit enter instead of shift, but we can fix it. 21 times 32, that product is 672. 672, x to the 4th, y to the 5th. 7 times 64, that's our next product. And that's going to give us 448. X squared, y to the 6th. And lastly, we got plus 1 times 1 times 128. That's just going to be 128. My x term is going to fall out since it's raised to the power of 0, and y to the 7th finalizes the expansion. Well, thank you for joining for these 3 examples using the binomial theorem to expand binomial powers. Thanks for joining. See you soon.